In this video, we're talking about Lab 5 Part 3, the part where you write the encryption program. And so this part has a long lead up where it helps you build the code incrementally. So let's read through it together. So first it talks about lists and how lists can be a really efficient way of processing a collection of items. They work well because they have lots of useful tools that can tell us things like the length of the list, and also because count control loops work well with lists. Because we can figure out how many items are in the list, that we have a tool that lets us do that. And we've also talked about how strings are really like a special kind of list where each individual element in the list is a character. And so we're going to be building this encryption algorithm that allows us to encode various characters and shift them over. So like if we had the message B and we wanted to shift it over 3 spaces, that would make the new encrypted version of the B an E. We could do that for any letters in the alphabet. That particular brand of encryption algorithm is a simple kind of encryption. You wouldn't want to use that if you were like transmitting your credit card number or some personal information over the internet, but it works just fine for like simple messages that you just want to hide a little bit. And this particular algorithm is called the Caesar cipher. So it just gives you us an example, like if we wanted to encrypt hello, first we'd encrypt the H by shifting it over 3 characters to get K, the E shifted over 3 characters as an H, L shifted 3 characters as an O, and the O shifted 3 characters as an R. So the encrypted version of that would be KHOOR, the encrypted hello. So we're going to think about how to create a program that will perform this Caesar cipher on a text message that's entered by the user. The user is also going to enter an integer key that should be used for encryption and should display the encrypted message at the end of the program. So the lab asks us to create an IPO chart for that. And the input there, it tells us what information is going to be required. The text message is going to be entered by the user, so that's part of the input. And it tells us the user will also enter an integer key value, so that will also be input. And the processing step, you can just write that you're going to use the shift algorithm on each character in the message. It says don't worry about the details yet, and then the output is going to be the encrypted message. It tells us that's what displays at the end of the program. So your IPO chart would look something like this. You're going to receive the message and the key as input, use the shift algorithm on the characters, and then create the encrypted version. So now it's going to walk us through a little bit of information that we need to know to create this algorithm. We're going to need to know about ASCII values. And ASCII is just a way that the computer stores data about individual characters. Remember, the computer likes to work with things in numbers because that's easier for it to process. So it actually changes all the letters that we type in to be numbers. And one of the ways it can do that is through using ASCII. And good news, you don't really need to know a lot about this because the computer handles it all for you. It has a method built in that allows you to enter a character and change it into a numeric ASCII value. And so those 3 lines of code are provided for you to get you started with the encryption algorithm. And it says just write the program that includes those 3 lines and then test them out. Make sure you always get the ASCII value that's shown there. So we're going to run our program, make sure that it works. Oh, and I copied and pasted from the lab code. That's always a bad idea. When you do that, you got to switch these little curly or the little double quotes because they're different in Word than they are in the Python keyboard. All right, I think I got them all now. All right, so it says enter a character. So if I enter the H, it's going to tell me the ASCII value is 104. And we can look that up on the chart and see if that's right. H is 104. Looks like it's good. So now we're going to think about how to use the ASCII values to achieve our Caesar cipher shift. If we have the ASCII value of a character, and we know how to calculate that, that's those 3 lines of code that we just wrote, then we can add the key value to the ASCII value. So like if A has the ASCII value 97, and we want to use a key of 3 to encrypt it, we would add 97 plus 3, that would give us 100, and then we would need to convert the ASCII value 100 back into a character to get the D from the result. So the key step there is that you have to add together the key value and the ASCII value in order to get the encrypted ASCII value. So our next goal is to add on to the program using that idea so that in addition to reading in the character and finding the ASCII value, the updated program also asks for a key and then calculates the ASCII value of the encrypted character. So I'm going to add my extra instructions to read in the key value. That has to be an integer. So I'm asking the user to enter a key, and I'm storing that as an integer. And then I'm getting the ASCII value of the character. I can print that out. And then I want to get the encrypted, or what did I call it in here? I called it ASCII value of encrypted character. That is the key plus the ASCII equivalent. So that's like adding the 3 and the 97. And then it tells me in here that in order to get the encrypted character in the end, I need to use this other function, CHR, that's going to turn my ASCII value of the encrypted character back into a letter. And so then I would be able to print this out to the screen. I'm just supposed to add a line that says, so the encrypted character is, and then the value of my encrypted character. All right, so let's test that out in our program, make sure that that much is running well. That'll be everything we need to process a single character. So if I have like a H and I shift it over 3, then it tells me the encrypted ASCII is 104 and that the encrypted character is K, which is what we expected. So it's good. Everything here is the data that, or the instructions we need to take one character and a key as input, then to find the ASCII equivalent of the character that was entered, then to encrypt that value using the key just by adding the 2 values together, and then turn the encrypted value back into a character using the CHR method. So at this point, we're ready to add some repetition statements to our program. We want to repeat this algorithm for each character in an original message. So we're going to change our program. Rather than just reading a single character, we want to read a message. And now we want to apply all of these individual instructions, the ones that process a single character, and create the encrypted version of it, and then create the encrypted letter version of it. We're going to repeat all of those for each character in this original message. And it reminds us that we can access individual elements, individual characters within the message using this syntax. So if we wanted to find out what's the 3rd item in the string message, we would say message at square brackets 2, or we could put in a variable that stored the value 2. Either one would be okay. Now it challenges us to create the final version of this algorithm, print out the entire encrypted message. So to do that, we need our repetition statement in here. So we have our choice of using a event-controlled loop or count-controlled loop. And I think a count-controlled loop is going to be better because once the user enters the message, we know how to find out the length of the message. The length is, we can find it using that len method or function. If we say len message, it'll tell us how many characters are in that message and store it in the variable length. And then we can use that to say that we want to keep going with our loop while the count's less than the length of the message. And then we're going to need to do all of these statements for each of the individual characters in the message. And remember, we can get a single character out by saying character equals message at index count. That's our value that's going to change throughout the execution of the loop. So the first time through it'll be 0, second time through it'll be 1, and so on. So each time it'll be pulling a new character out of my message. And then finally, I want to update the value of count. That's always my update step for a count controlled loop. So I need to include that in there. Let's think about this and see if we have all the steps we need to take a message and create an encrypted message. So we ask the user to enter the message. That seems good. We ask them to enter the key. Great. We found out how long is the message, how many characters are in it. We set up our count controlled loops that's going to repeat the correct number of times based on how long the message is. We pull the next character from the message using our square brackets to access any individual character. Then we converted that character to its ASCII equivalent. Our final version of the code, we don't need it to print out the ASCII value of the character. We already tested that and know it's working right. Then we need to calculate the encrypted value, the encrypted ASCII value for the character. That's cool. And then we're going to turn the encrypted ASCII value back into a character. The last thing we need to do is add that encrypted character onto a longer message. I'm going to call it encrypted message. And I want to concatenate that new value onto the character or onto the message at each iteration. So taking whatever character I create here and adding it on, concatenating or joining it to that message. And I'm going to initialize my encrypted message up here just so that it has a fresh start. It's an empty string. And then at the end, rather than printing, so the encrypted character is, I want to print out encrypted message equals, and then I'm not going to print just the single character, I'm going to print the whole message. I think that's going to be everything I need to accomplish my goal in this program. Let's see, if I type in hello and a key, I get the encrypted message. And obviously we should test it a few more times, but it looks like we are on the right track. Seems like a good solution to the final part of Lab 5.